appears that it might be going to. Okay, so the first thing that we're going to do today is we're going to simplify variable expressions when we have these fraction exponents involved, when we have rational exponents involved. So we're going to apply what we learned yesterday, and then we're also going to have to apply some properties that we learned a while back. We have all kinds of properties of the powers that we learned. So the first thing we're going to do with this one is we're going to rewrite it as a power rather than with the radical sign, because we learned yesterday that if we have the nth root of, let's see, how did it go? I can't remember how I wrote it. B. No, the nth root of b, radical b, is the same as b to the 1 over n power. We learned we can write it with a radical sign. We learned we can write it with a fractional power. So we're going to get rid of the radical sign in this one, and we're going to say, well, this is really the same as y to the 4th, or x to the 4th, y to the 12th, being taken to what power? 1/4 power, yeah, to the 1/4 power. Okay, well now we're going to go back in our memory bank and say, we know what to do when we have powers. We have a product going on here, because in reality there's a multiplication, an invisible multiplication dot there between that x to the 4th and that y to the 12th. So we have a product to a power. We learned that if you have a product to a power, you give each of those factors that power. So next thing we're going to do is we're going to give x to the 4th, and we're going to have to put it in parentheses because it's already a power. And we're going to give it the power of 1/4. And then we're going to give the y to the 12th that 1/4 power also. Each factor gets that power applied to it. Well, the next thing we have to do is apply the property that says you get a power to a power. What do you do when you have a power to a power? What do you do with those exponents? Multiply them. So now, and we're going to show all these details in our notes so that we can see what were we exactly doing. We're going to take x to the 4 times 1/4 power. We're going to multiply those powers. So 4 has to be multiplied by 1/4 in the exponent times y to the 12 times 1/4 power. Okay, what is 1/4 of 4? 1. So that becomes x to the 1st power times, what's 1/4 of 12? 3. So times y to the 3rd. And now I can do what? Just clean this up, right? What does it become?
X, y to the 3rd.
Yeah, x, y to the 3rd power. Okay, now remember, we said yesterday, here's what this really means. Whether it's in this form right here, when the radical sign is there, it's showing the 4th root of x to the 4th y to the 12th, or it is x to the 4th y to the 12th being raised to the 1/4 power. They both mean the same thing. It's asking what times itself 4 times will give us x to the 4th, y to the 12th. That's really what we were looking for. What times itself 4 times will give us x to the 4th, y to the 12th. So we have just decided that that is x, y to the 3rd. X, y to the 3rd. It's multiplied by itself 4 times. Would it get us that? What do we do when we multiply same bases? What do we do with their exponents? X to the 1st times x to the 1st times x to the 1st times x to the 1st. What do we do? Add them. 1 plus 1 plus 1 plus 1. So altogether we have x to the 4th power. Y to the 3rd, y to the 3rd, y to the 3rd, y to the 3rd. We add those 3's. 3 plus 3 plus 3 plus 3 is 12. So it checks out, doesn't it? This is like a check problem right here. We're saying what we got multiplied by itself 4 times does take us back to what we started with, what we were trying to find the 4th root of. Okay, so any questions on that one? The book might go about it a little bit differently. Or Or it may have handled it like this, I don't know. I always try to put it together in first of all, the flow from what we did yesterday, and second of all, trying to make it, a little easier to understand.
Well, the book doesn't.
Okay, so again, it does a little bit different.
Yeah.
We have fraction now.
Ooh.
So what we're going to do is we're going to take that numerator and that denominator and work with them separately, keep it as a fraction, in other words, until we're ready to get rid of the fraction. So xy to the 1/2 power, that is being squared. That's a product to a power. What did we just do with a product to a power up there?
Well,
Give each factor its own power of 2. So x has to be taken to the power of 2.
why?
Y to the 1/2, because it is already to a power other than 1.
And then you put.
And then that has to be.
Outside.
Yeah. So each factor gets its own power of 2. And then downstairs, we're going to rewrite that radical as a power. A power name could we give the 5th root of x to the 5th?
X to the 5th to the 1/5.
Yeah. X to the 5th power. I have to go in parentheses because it's already got an
Yeah.
exponent. And we're going to write another exponent to the 1/5 power. Okay, and like I said, we're going to show lots of steps. You're going to be like, why do we have to be so detailed? Well, first of all, these are notes. We want to be able to follow what we were doing. So now, that x squared, we don't really need to, I think I need to use a different color here. That x squared can just stay x squared. What are we going to do with that y to the 1/2 raised to the second
Multiply.
power? Multiply y to the 1/2 times 2 power. And then downstairs, we have a power to a power. X to the 5 times 1/5 power. Well, x squared is going to remain x squared. What's half of 2? 1. So that's going to become y to the 1/1 power. What's a 5th of 5? 1. So that's going to be x to the 1st down there. Ricky?
I think I know the next step.
Okay, what's the next step?
Since you have two x values on the top and one x value on the bottom, you could
How do we divide powers that have the same base?
multiply.
No,
Add.
no,
Subtract.
subtract. Okay, so what we're
I
going
know
to
you
do,
told me
let's
this
just,
morning.
yeah, so let's just write this again so we can show it separate. We don't wonder what happened from the results of that. Let's just write that again. So take the time to write that again. Because there's no addition and no subtraction going on in this problem. It's just all multiplication and division. What we can actually do is we can divide these guys right here. They have the same base. They're both base x. Okay, Ricky, be done. So now, when we do division, what we actually do is subtract. We take the top one's exponent and we subtract the bottom one's exponent. We don't need, so that base, what we're doing is dividing. We're taking that out of being a denominator. It's coming up. And we have times y to the 1st. So there's no more denominator. We divided that x out of there. And now we're going to say, we have, what is 2 take away 1? 1. So we have x to the 1st power times y to the 1st power. And that is what?
XY.
xy. Our answer is xy. This one would be a whole lot trickier to check. We're just going to trust because it looks so nice, xy. Can't be much nicer than that, huh? We're just going to trust because it looks so nice, it's the right answer. Okay? So, any questions? We're being very detailed in our work here. Do I have to necessarily see exactly all of these steps? Only if you need to make sure you're getting the right answer. But if you go right from here, when you're right here, to this one, because you know that you have to multiply those and that's what has to happen. You go straight, you skip the red step, that would be fine. But we're just reminding ourselves of what the properties are and how we handle the different types of things that are going on with the powers. Okay, let's do this next one together. Then I'm going to have you do number 4 on your own and see how you do. Okay, so let's start with our numerator. We have a power to a power. So we're going to show z to the what? 1/3 times 3. And downstairs, we're going to rewrite that radical as a power. What would that be? Z squared, or z to the second power, to the...
third. Second power.
1/2 power. What root are we looking for? We're looking for the square root, so that's the half power. Now we can say, okay, 1/3 of 3 is
3.
1. What? 1/3 of 3 is 3?
1.
Trust me, if I have $3 and I'll give you 1/3 of it, I'm not giving you all of it. Okay, and this one we're going to do z to the 2 times 1/2 power. Remember, we're showing all the steps right now. And then we're going to say, okay, well, z to the first upstairs. What's downstairs?
Z to the 1.
Z to the first. What's the final answer?
Z. 1. Z. Z.
Z1. Anybody want to go over 0?
Z.
Huh. Well,
Going once.
anything divided by itself except for 0 is 1. 7 divided by 7? 1. Y divided by y?
Y.
1. Anything divided by itself is 1. Now, I'm pretty sure I haven't convinced all of you that when there's variables involved, that's true. But I'm just going to do something down here to show you what would happen. This is a division problem, right? So z to the first divided by z to the first, we would subtract exponents. 1 take away 1. Right? Am I doing something legal here? Okay. What is 1 take away 1?
0.
0. Oh, what's anything to the 0 power except 0 itself? 1. Ah, yeah, it's 1. Okay. So the answer is 1. Okay, try that last one on your own. See if we all end up.
Oh my goodness.
I'll do it, you do it your way, and we'll see if we all get the same answer. My final answer is circled in black at the end. A to the 8. B. Did it happen? Again, we just keep applying all of this. Everything that we have done up above, anything going on here, use the properties that need to be done to help us simplify powers. We have lots of properties and powers. Okay, any questions about any of these before we go back and work with non-variable. Fractions being taken to fraction power. Okay, so we're done with this side?
I don't think they like me.
No, I think it's the other way around. You guys have a phobia about fractions for no reason at all.
Well, I got reasons.
Okay, so we have a fraction to a power. Oh, back when we had fractions to powers before, we had something like maybe x to the third power divided by y to the second power, and that was taken to the fourth power. We did this stuff. What did we do to simplify that? We had two choices, but I want us to apply the property. So what we did is we said, oh, give the numerator its own power and give the denominator its own power. And that's how we went about simplifying. So what do you suppose we're going to do here?
Same thing.
Same thing. We're going to give that numerator its own power of 1/3, and we're going to give that denominator its own power of 1/3.
Okay.
And then we're going to say, oh, I know what that means. That means I need something times itself 3 times that equals 8. And I need something times itself 3 times that gives me 27. So what is the thing, the root of the third root of 8? 2. So that's 2. So we say, oh, okay, well, 8 to the 1/3 power is 2. And what is the other one?
3. 2/3.
So 3 times 3 times 3 is 27. So the third root of 27 is 3. So there's my answer, 2/3. And look at my little reminder here. Remember, we know what it means when you're taking something to a fractional power. It means what times itself 3 times will give you that 8/27. So in other words, the answer we get when we take it times itself 3 times, it better get us 8/27. Does it? Yeah. What times itself 3 times, that's what that means, gives you 8/27. 2/3. And 2/3. And 2/3. So it checks out. It's nice. Okay, let's try the next one when the numerator isn't 1. Remember yesterday when the numerator wasn't 1, we wrote it as a power to a power. So who wants to offer up what they think how we could rename this one? Ashton?
So we 4 to 3/2.
Okay, how about we do, first before we do that, we could do it this way, but how about instead we first just rename it as a power to a power like we were doing yesterday when we had a numerator greater than 1. Let's start there. So do you remember how that went? Brianna?
4 to the 1/2 to the third.
Can I make the whole fraction that way?
That's,
Can I do this? Whatever was being taken to that power, can it be taken to the 1/2 power? And then that's going to get, that answer is going to get what?
Take it to the third.
To the third power.
Okay.
So in other words, what times itself twice, that's what we're really looking for. What times itself twice is 4/49ths. And that cubed. That taken to the third power. Now this isn't the only way to attack this. Both of you kind of wanted to do it a little bit different way, and it should get us to the same answer though, okay? But this is the way I intended to show it, so I'll just show it this way. I'm not sure how the book would. So now we're just going to work inside out. We're going to say, oh, this can be renamed as, like Brianna was going to go to, 4 to the 1/2 power over 49 to the 1/2 power. And then that has to get cubed, right? Well, what this is really looking for is what times itself equals 4, and then downstairs, what times itself equals 49. So what does 2? So that means we're gonna have 2 over 7 times 7 is 49, so 2 over 7, that's becomes what's inside the parentheses, and now that still has to be cubed. Now, there's 2 ways to go about this now, we're still not done. We can do it as just the product property, or the fraction to a power property that says give each of them their own power of 3, right? That's one way to do it. Or we could say 2 sevenths to the 3rd power really means this. This is the longer way of writing it out.
Oh my
Same thing,
goodness.
right? Isn't that the same thing as that?
Yep.
Well, what is 2 to the, no, remember, no calculators on this quiz. So what's 2 to the 3rd power? 8. What's 7 to the 3rd power?
343.
Oh, how'd you get that?
I use my mental math.
Oh, you use your mental, or you mean you use your pencil and your multiplication skills? That's not mental math.
That's what I use.
This is mental math. Doing it without anything, standing here and saying 7 to the 3rd power is, okay, well, first of all, what's 7 times 7?
49.
49. Well, 49 is really close to a really nice number, 50. 50 times 7 is 350. I went up 1, didn't I? 7 times. So let's take away 7.
43.
343. That's how you do it with mental math.
But I also use
Mental math means you don't put a pencil to your paper. But I get, what you're saying. Okay, so 8 over 343 is our final answer for that one. Okay, now you do number 7 on your own. See if you can get the right answer. No pencil mental math this time, Ricky.
Okay.
Okay.
I didn't usually do calculation in mine this time. I thought. Before I wrote down. And then I wrote down. Wait.
$16,620. Sound good? Okay, so again, these are very actually not hard at all to do with other calculators. You just apply the properties. You should start by now. You should start memorizing some of these. If I say to you, what's the 3rd root of 125? 5. What's the 4th root of the 4th root of 81?
3.
3.
Oh.
What's the 3rd root of 64?
4.
4. What's the 5th root of 32? 2. So some of them, as you work more and more, they should be starting to go into your memory bank.